Let's go to Lico 2684, max number of move in a grid. So you are giving a zero index and multiplied by matrix grid consider positive integers. You can start at any cells in the first column of the matrix and traverse the grid in the following way. That is, from cell row column, you can move to row -1, column +1, row columns +1, and row +1, column +1, such that the value of the cell you move to should be strictly greater than the value of the current cell. Return the maximum number of moves that you can perform. So, the things that let's look at the example. If we initially we can stand at any cell in the first column, right? And we can move next move. There are three choices to move, right? Up and the same row and move down one row, right? And to the right, and also we need the next cell should be greater. So there is one of the root is we're going like this. 2 goes to 4 and goes to 9, goes to 11, right? So let's see. So the maximum move is 3. This is one move. Second move is third move. Actually, this is not the only answer, right? It can also go from 3 to 4, and it's 4 to 13, and 13 to 15, right? So how can we do this question? What we're thinking about is that we can try to say if a row, right, a cell, we are able to send on a cell that need some kind of conditions that because this cell can come from also we can go to 3 directions, and that means this cell can come from three directions on its left up on the same row and in a row below, right? So for a cell row column, it can only comes from row -1, columns -1, row column, row +1, column row columns -1, row +1, and column -1, right? Can only coming from these 3. And we need these 3, it will be smaller, right? And if the previous cell it is true, that means we are able to stand. We can use the Boolean true or false. We are able to go to this cell, means we are going to go to row column cell, right? So in the end, what we need to return is a max column, which is has true, right? So let's write code for this. We can use let's say int m equals read dot length and n equals read 0 dot length. Yeah. So we just need to use a Boolean dp equals new Boolean m multiply n, right? So dp ij means at breed we are able it means be able to stand to go to breed I j. So initially, what's the value what's the initial value, right? Looking at stand or at the first column. So what is for int I equals to 0, I smaller than and I plus plus, I have dp I 0 equals to true, right? So then we can have a result. Result is int, right? Int. What we do is for int j equals 1, j is smaller than n, j plus plus. We should first iterate the j, then iterate I, right? But since we should do in like this kind of directions. That is, the outer loop is j, right? We are good because we are going to iterate in this kind of direction, right? Want to get for I equals smaller than m. This is not correct. Should be in the inner for loop. Then what we do is that for int I equals 0, I smaller than m, I plus. So there are three conditions. If the first one is I minus 1 is greater or equal to 0, right? The row and we'll say and dp I minus 1 j minus 1, right? This is from this part, and it can come from three cells. One cell can come in from 3 cells, and also we need grid I minus 1 j minus 1. If this one is smaller than grid I j, right? This is the first condition. Or the second condition is this condition we don't need anymore, right? Because if we have dpij, ij, I and j minus 1 should always be in the inbound, right? So we just need this. So it's not I minus 1, right? Just I and this. The third condition is so that is I plus 1 if it is smaller than m, right? And I plus 1 and this I plus 1 is smaller than this. Then we're going to have dp I j equals true. And here we can have result equals max result and j. In the end, we just return result. It's m multiplied by n time complexity and space complexity. Let's write the Python code for this as well. We'll have m equals m and n equals length grid and length grid 0. And we're going to have dp equals false and for in range. And whereas that initially that we are able to send at any rows in the first column in range m we're going to have dp I 0 equals to then we can have a result variable for j in range from 1 to n. For I in range m, let's say if I minus 1 and greater equal to 0 and if I minus 1 and j minus 1 and grid I minus 1 j minus 1 is smaller than grid I j right and we'll say oh mm, oh that is oh I we just copy this right if I and grid I and we have another O O I plus 1 smaller than M. For these kind of three scenarios, we can have dp I j equals true, right? And we're going to have result equals max j result. In the end, we just return result. X expected should have a common here. We should have this. I should have a space here.